Hi everyone, welcome to video 2 for lesson 2.5, which is dealing with absolute value functions. We're going to go ahead and investigate x-intercepts and y-intercepts of the absolute value function. So we actually have three cases that could happen. One of the first cases that we have is we could have a situation where there is one y-intercept, as you can see here. But notice that this one does not have any x-intercepts. Okay, so an absolute value function is not guaranteed to give you any sort of x-intercepts. As you can see, it kind of hovers over the x-axis. Another situation that we could have is where the vertex or the tip of the absolute value function is sitting directly on the x-axis. So that gives you one x-intercept. And as you can see again, eventually the absolute value function will give you one y-intercept. Okay, and then finally we have a second one where we can clearly see that we have two x-intercepts and again only one y-intercept. So I definitely encourage you to see if you can come up with any other examples. Definitely jot down a coordinate plane, try to put down as many different kinds of absolute value functions as you can, and see if you can come up with any of the other three cases that besides the ones that you see here. But basically we're going to go ahead and use these kind of visuals in order to move into actually calculating the vertical and horizontal intercepts. So the problem that I have given you here is going to be f of x is equal to 4 times the absolute value of x minus 3 plus 4. So if you recall, the plus 4 on the outside is telling you that your absolute value function is going to go up 4 units. The minus 3 on the inside of the absolute value function is telling you that you will move your absolute value function to the right 3 units, and the 4 that you see out in front would tell you that you are going to do a vertical stretch by a factor of 4. Okay, so let's bring this back so we can see everything clearly. So what we're going to go ahead and do is, first off, we're going to investigate the y-intercept. This is also known as the vertical intercept. If you recall, a vertical intercept's coordinate point has the standard look of a 0 in the x position and then some number in the y position. So if we were to go ahead and actually evaluate this, finding vertical intercepts are pretty easy and quick, which is nice. We can see that we will have 4 times the absolute value of negative 3. Then we would take the absolute value to get 4 times positive 3. Using our order of operations, we will continue and do the multiplication. So now we have 12 plus 4. And we wrap this up and say, well, my y-intercept is at 0, 16 for this particular function. But now let's move over to studying the x-intercept, also known as the horizontal intercept. And it should make sense since the x-axis is the horizontal line. And as we had discussed in previous classes, especially with our focus on linear equations in this chapter, the x-intercept would take on the structure of an x value in the x position and a definite value of 0 in the y position. Okay? So that means that we're going to set the function equal to 0. So some things to remember before you can solve an absolute value equation, recall that you need to get the absolute value isolated. Okay, so any values that you see either being multiplied, added, or subtracted outside of it, they need to be removed from where the absolute value is. So in this situation, I'm actually going to go ahead and subtract 4 first to start clearing that. So now I have negative 4 is equal to 4 times the absolute value of x minus 3. But then I can do better, because now I want to undo that multiplication that's happening between the 4 and the absolute value. So I can clear that. And this leaves me with negative 1 is equal to the absolute value of x minus 3. Now, if you recall, the absolute value is measuring a distance. So right now, what this statement is saying is I have a distance that is equal to negative 1. So from the first video, can you remind me, can I have a negative distance? And hopefully you're saying, no, this is not possible. So since I've arrived at a false statement, I can actually conclude that there are no x-intercepts in this case. Okay. Please continue on to video 3, and we're going to take a look at a more comprehensive example. Also, just to let you know, random question number 1, how many pairs of glasses does your teacher own? He owns 6. Please continue to watch through the next couple videos. And if you have any questions, please feel free to message me.